So, first talk of this conference all about character animation. And here's this idiot talking about everything but character animation. We'll make sense of this in a second. First of all, yes, I'm Kopic. I create video tutorials for Entagma. I try to come up with a job description, what I do at Entagma, but I think we'll just leave it at this. However, this is what I get to do for a living. I'm very grateful for that. I get to play with Houdini and record funny videos about it. And this is how I make my living. If you want to meet me on the show floor and for some reason you don't want to talk about Houdini, I don't know if you know this, but if you're a motion design guy in Germany, it's required by law to be a huge bike nerd. So I'm happy to talk about this. Or electronics or sewing as well. But back to topic. This is KineFEST. And basically, as soon as I heard the title of this conference right here, I was like, yeah, I know exactly what I'm going to talk about here. And to explain this, we have to go back a bit. We have to go back to 2021. This is me with a very bad case of lockdown here. But also what happened during that year is I just finished my first big video series for Entagma about PDG. And once you finish such a series, you're always in this sort of limbo where you're thinking about, hey, what can we cover next? And I was thinking, hey, there's this new rigging tool in Houdini that SideFX seems to be very chuffed about. And I'm not a character animator, I'm a MotionFX guy. But it seemed sort of open and hackable. So let's maybe try to get some motion graphic setups out of it. Maybe do like 10 videos and then be done and move on to the next topic. Well, let's jump forward 2 years. I'm now over 30 episodes into this whole course. I now have shoehorned KineFX into pretty much every part of Houdini. I'm having the time of my life just coming up with new funny ideas on how to use KineFX where no KineFX is supposed to be. And I'm now officially a Kine fan. And my mission today is to turn you all into Kine fans as well. First of all, a couple of disclaimers. So most of these setups that I'm going to talk about today happened before Apex was announced. So I will use little to no Apex, let's call it that. However, we just also launched a free Apex course done by Magnus Möller, who has done an amazing job. I can just highly, highly recommend checking out those videos. And also, second disclaimer, again, I'm a motion graphics guy, I'm not a character artist. There will be some terminology butchering here. I know perfectly well for you guys, something like a skeleton and a rig are two different things. It's not for me, and it's going to show, so bear with me. But let's talk about why I think KineFX is so great, and why it's so great is it's basically the same reason Houdini itself is so great, because everything in Houdini is just built from the same building blocks. So we can just take a look at this one humble polyline here. And just this one polyline could be a guide groom curve, it could be a Vellum hair object, it could be an RBD constraint, it could be a KineFX skeleton. And now with Apex, I guess it could even be an entire node graph in and of itself. And the only difference between all those very different things inside of Houdini is it's just different attributes on that single polyline. And if we switch out those attributes, our single polyline can become all of those things and convert between all of those things. So since attributes are so important, let's quickly just go over the attributes that KineFX wants, that a KineFX skeleton wants. First of all, very simple, we have a name attribute. This is just a different name on every point of a polyline. And this is just there in the end for capturing, so that we can take one point of our character skin, and that point can say, hey, I'm 70% influenced by bone 1 and 30% influenced by bone 0, and this means if those bones move, I'm going to move to that location. This is all there is to it. The next, we have a tag team of attributes. We have a P and a transform attribute because, well, we want to start the transforms on a rig. So the translation, rotation, and scale. And this is again done by two attributes. The P attribute, this is your bog standard Houdini P attribute. It just saves the position as it always does. And then the transform attribute is a 3x3 transform matrix. And if you know your transform matrices, you know that these are able to store rotation and scale. So there you have all your attributes. However, matrices are sort of scary and difficult. The one practical thing to keep in mind here is in Houdini we have a bunch of attributes that can store a scale and a rotation. So for example, a p-scale attribute or an orient attribute. And we can just combine them and turn them into a transform attribute. Or we can take a transform attribute and split it up into a p-scale and orient attribute. We can sort of switch between them. And this is always going to be the same setup that you just have to remember once and then use in your setups. And then finally, the last thing that we need is the vertex order. And this is there to store the parent and child relationships of our rig. And the vertex order is somewhat of a weird thing because it's not an attribute. To quickly summarize this, in Houdini, everything is built out of two things. Everything that we can see is built out of two things, prims and points. So prim here, or primitive here, is a polyline. This is just the concept of a polyline. It does not have a shape yet. And then we have the points, and these are just positions in space that give this polyline its shape. But what's telling Houdini how to connect the polyline to what point? And this is what vertices are doing. So vertices are sort of like the glue between points and primitives inside of Houdini. And vertices have this really interesting property that they're always in order. They're always in an ascending order. So we can just take a look at one point and its vertice, and just take a look at the index and the indices, or the indices of the points next to it. And this is how we get a vertex order and therefore a hierarchy. But really, all you need to know about here is this typically just works in Houdini and you don't have to worry about it. But finally, what I want to summarize in here is we have this very short list of attributes that we need to worry about. And once we have this on some part of Houdini, we have access to all of those nodes that KineFX gives us, and which we can use for a ton of different things. And now we're going to get to the fun part of this presentation, where I'm just going to point at random things inside of Houdini and tell you, hey, that's a rig, and now we can animate it with KineFX. So let's do just that, and let's maybe start simple. Let's start with, a point is a rig. Because yeah, I talked about polylines a lot and about vertex order, but just a single point inside of Houdini with the right attributes is a functional rig, and we can use it for like a bunch of really handy stuff inside of Houdini. So let's say we just have a setup like this. We build something inside of Houdini that consists of some objects, and we want to make some tweaks with them. We can drop this very old school node inside of Houdini, the assemble node, where we can pack the geometry. And now we have a bunch of points, and these points have a name attribute. So we're on the right track for a KineFX rig already. So what we can do next is we can just drop down an add node and just delete everything but the points. And then we can use one of those KineFX nodes, the rig pose node. And this allows us to get, well, transform handles on all of our points. And then in the end, if we want to take those handles and move our geometry with it, there's this other handy node, the transform pieces node, where you can just wire it up like this, make this one checkbox here to invert the transformation, and now we can just use this very clean little setup to just make tweaks to all of our objects. And it does not matter how many objects you have in your scene, this just always works. This always builds you your transform handles for your objects. And then finally, in the end, you unpack your geometry again, and you're left off where you started, just now with some tweaks. Let's keep going. Let's say we want to scatter some objects onto our main scene right here. And there's this one object that does not look right. We want to tweak it. Take a look at the attributes again. We have an orient attribute. We have a p-scale attribute. So again, we are pretty much on the right track to have a rig here. We just have to convert it to a transform attribute. So for this, let's just drop down a point VOP, dive inside. We can get rid of those nodes. And first of all, we want to bring in our orient attribute. This is in Houdini a so-called quaternion, which is a 4-dimensional vector. You don't have to really care about what all of this does. You just have to remember that this is how you import it. And then there's this one node, quaternion to matrix, where we can turn it into a 3x3 matrix that KineFX wants. Then we also have to bring in our scale, our p-scale. So again, bring this in via bind node. And there's one very simple node, just a node that's called scale, where we can apply this p-scale to our matrix again. And then finally, we can just export that out, export it as a transform matrix. And hey, we've now turned a bunch of points into a functional rig inside of Houdini. So again, we can do the same thing as before. We can drop down a rig pose node. And now we have a bunch of transform handles on every point that we scatter, where we can just pick out some points that we want to tweak and just do a little tweaking in there. But that's static geometry. That's a bit boring now, is it? Let's try if we can do the same thing for like a simulation. So let's say we have a rigid body simulation like this. And again, there's this one piece that just landed awkwardly here, and we want to tweak it. Let's take a look at one of those outputs of the RBD bullet solver, and we have a bunch of points. And again, we have an orient attribute. And again, we have a scale. And again, we have a name. So this is basically just a rig output by the RBD bullet solver. All we have to do is build the same node tree as before, bring in an orient attribute, convert it, bring in a scale, apply it, export it out. And then we have this little setup down here where we can go into a simulation, into our animated geometry, and just take a look at this one piece and just tweak it, make it sit the way that we want to have it in the end. Something like this. And then the only thing that we have to do is we have to add a little transitioning animation to just hide this piece that we changed, or to hide the transition of the piece that we changed. Put it somewhere where there's just a lot going on. And now if we play our simulation again, now that one piece is landing perfectly like we want to. And again, we're just building all of this with nodes that were never made for this purpose inside of Houdini. We're just coming up with our own use cases here. So this is what a point in Houdini, or why a point in Houdini is a rig. Let's turn another thing in Houdini in a rig. Let's just keep going. Let's turn the Vellum into a rig. So what we're going to build here in the end looks something like this. This is the animation in the end. Bit of a spooky animation, but this is what I came up with. And we're starting out with your typical KineFX rig, and this is the maximum of my character animation skills right here. So we have our character rig right here, this disembodied arm and the skeleton. And you can take a look at the skeleton and sort of think, hey, this looks like a Vellum hair object. This looks like something I could simulate. So why not try simulating it? Let's take a look. Let's see how this looks. And yeah, just the skeleton by itself, run through a Vellum solver, works perfectly fine. We don't have to tweak anything here. But let's see if we can animate our arm with this, and no, we have some work to do here. So again, let's take a look at the info. We got a bunch of attributes right here, but if you take a close look, we also have an orient attribute here. So we already know what's this all about. We can try converting this again into a matrix. So this is exactly what we're doing here. Taking orient in, converting it to a transform matrix. This is what KineFX wants. And let's see what we get now. And yep, this is kind of working, but the fingers, they are a bit odd. They don't work yet. So let's take a look at what's going wrong here. So what we're seeing here are the skeletons that Vellum creates and that KineFX creates. And if you take a look at the transforms on the arm, those are just matching up perfectly. And this is why the arm does not have any problems. However, if you take a look at the fingers, those fingers are completely different. And this is why they're mangled again in a simulation. So we have to get a bit more creative here. We have to get a bit more mathematical here. However, the nice thing is you have to just remember this once, and then it will work for every KineFX Vellum setup there is out there. So I'm bringing in my skeleton, and I'm bringing in the attributes that I need from my simulation. And then I'm also creating a freeze frame of the animation, just the first frame locked in place. And then this goes into this point warp down here, where we can do mathy things with it. Let's put it this way. So again, we're bringing our orient attributes, and this time both our static orient attribute and our animated orient attribute. And then we're going to apply it to a transform matrix. And we will apply it in a very specific way. So we're first of all going to multiply our static matrix in its inverted state. We're going to invert it and then multiply it. And then we're taking our animated orient attribute, or our animated matrix, and we're just multiplying it with it. So what we're doing in the end here, this seems very complex, but all what we're doing here is we're just calculating the offset between our static orient attribute and our animated orient attribute, and we're just applying the offset to our actual KineFX matrix. This is what we're doing here. And then in the end, this gives us the perfect transforms that KineFX wants. And again, this is the same setup all the time. So you just have to remember this once. And once we have that, we can just hit play. And now our KineFX rig is working perfectly together with Vellum. And now we can just do KineFX stuff with it. So we can drop down another rig pose node. We can add a little pose in here. Now it's doing this. Then we can add a skeleton blend to add a little animation where we go into this pose. And then in the end, we can again just run it through a bone deform. And now we have this little funny animation right here. So we turned Vellum into a rig. What else can we turn into a rig? Let's see. How about we turn diffusion limited aggregation into a rig? And now this is the point where you know that you're inside an Entagma presentation. So first of all, let's take a look at diffusion limited aggregation. This is a somewhat old video of ours where we built this the first time. And it's this sort of growing, branching, organic thingy in the end that I really quite like. But if you take a very close look at this animation right here, you notice that every point that we're adding in here, every point is just popping into existence. It just appears out of nowhere. And that's not very motion design now, is it? We do want a nice animation on there. So could we use KineFX to make this look nicer? Let's see. So this is the second version of diffusion limited aggregation that we built. And now we have just a ton of little animations for every point that we're adding on here. And I think this is looking a lot more organic in the end. So let's see how we can build this. Let's first of all get a quick refresher of what diffusion limited aggregation actually is. So what we're starting out with is basically particles. And we have two sets of particles, or two types of particles. We have particles that are already stuck in place, that are already building this branching structure. And then we have some free-flowing particles somewhere in our scene. And what we check is, hey, does one of those free-flowing particles get really close to one of those stuck particles? And if it does, then we just make it stuck again, or stack as well. And this way we are growing this branching structure right here. But if you really think about it, one particle getting stuck to another particle is basically like a parent-child relationship. So one's free-flowing particle is the child, and the particle it got stuck to is the parent. And if you do this for all these single particles in your entire simulation, then you should have a working rig hierarchy in the end. So let's try that out. So first of all, this is my base DLA setup. This is just a simple pop simulation. We have a pop source, just some points where we can spawn new particles from, like this. Then one curve that we're going to use for a force in a simulation, and then just a bunch of points, some initial points for other points to get stuck to. And then inside our simulation, this is also for Houdini standards pretty simple. We have a source for our particles, then we have a curve force, then we have just a node to kill our particles outside that blue boundary. And then our entire logic for our DLA is just in this very short point wrangle in here. So first of all, we are creating a certain search distance around our particle. And then for this particle, we're going to check if some other points are near it. So either points down at the center or points that are already stuck, that are part of this branching structure. And if one of those points is nearby, then we're going to stop our active particle. We're also going to put it in the stopped group. And we're also going to save the current timing, the point in time where it got stuck. We're going to save this in this timing attribute that we're going to use later. And also, if one of those stop points is nearby, we just want to take its ID attribute and just save it in a parent ID attribute for later, for building our rig tree. And if we run this, we now have this branching structure here built for us. So then, we can try turning it into a rig. First of all, again, we're going to freeze frame it. Just pick one frame where it should stop. Then we're going to delete all the attributes except the ones that we need for our rig to work in the end. Then we're going to remove all remaining flowing points. And then we have this little wrangle right here, where we're basically going to check, hey, do we have a point stored in the parent ID attribute? And if so, we're going to get that point. And we're going to just draw a little polyline from the parent to the child. point, like this, to a current point. And if we do this, we have this giant branching structure now, and this is a perfectly fine KineFX rig now that we can animate. So we're going to do a little bit of tweaking right here. We're going to first smooth it, make it look a bit nicer. And then we're just going to quickly add on our transform attribute just with this one pre-built node inside of Houdini, and that works surprisingly well. And then we can use also this timing attribute that we saved earlier, again with just one line of X, and create this ramp right here, traveling up or growing along our object in here. And we can use this for driving our animation in the end. And this is just this one line right here. And since we're dealing with quite a lot of bones in here right now, we're not going to use a rig pose node. We're going to use the procedural way. We're going to use this rig attribute wrangle. We're just going to bring in our animation attribute. This is this ramp that traveled through our object. And we run it through a pre-rotate and pre-scale function, which is just like rotating and scaling a joint on a rig pose node, just now done with code instead of manually. And once we do that, we get this nice little growing animation right here. Let's watch this finish. Like this. And now once we have that, first of all, we're going to do some tweaks because in the end, again, I want to have random scaling on all my objects that I'm going to copy onto it. So this is what I'm quickly doing here. I'm just calculating a random Gaussian value on my point. And then I'm just bringing in my transform attribute again and applying it as a scale to this transform attribute. So finally, this is the structure that we built in here, and this is with the scale turn on and off, so you can see its effect. And then again, if we play this, you get the animation that you saw in the beginning. And I think this looks a lot more beautiful instead of just having every point in here just pop into existence. I think this looks a lot more organic and nice. All right, what else can we turn into a rig? Let's turn a flower into a rig. And in this case, it's going to be a large rig. Whoops, nope, I don't want that. So this is what the end result is going to be. And this is part of a larger setup that is able to create all those flowers that you're seeing here and many, many more. And this is the setup. Again, I said it's going to be a large rig, but this is the end result. And we're just going to take a brief look at this. If you want to see it in all its detail, we have a bunch of videos on how to create this. But let's first of all start up here at the top. And first of all, we're going to start out with a single petal. And this is just your typical procedural modeling that we're using here. And then we create one base KineFX rig for one petal. And then one neat trick that you can do with KineFX is if you have really nice UVs on your geometry, you can use a little setup like this. The Houdini veterans might notice this. This is a UV deformer. And we can just take the UVs of our object and this little setup in here to just deform our standard rig to this shape of our petal. And we always got beautifully matching rigs for all petals that we're going to create. So now we got one rig petal. But this is a flower. We need many more of them. And first of all, we're going to just use one of those standard copy nodes inside of Houdini to create multiple of those. However, in here, this is the only part where this gets a bit strange because those copy nodes actually break a bunch of those attributes that we talked about on the rig skeleton in the end. And it's a bit of a hassle to fix this. So in this case, I did what you then typically do as a Houdini artist. You just build your own tool, your own little HDA to fix all those attributes again. This is the only thing that's custom built in here. And then we have a bunch of flower petals, and they are all rigged. And we can again use KineFX to animate all of them. So what we can then do is we can use, again, a bunch of KineFX now to just shape our flower petals into a blossom. And again, these are those rig attribute wrangles. And again, very little code inside here. It's basically just a bunch of ramps where we can sort of intuitively shape the shape of our blossom into something beautiful. But again, this is still KineFX. So again, in the end, we can do KineFXy stuff with it. So why not try to build an IK rig on a flower? So we can just take our skeleton like this, and just isolate a bunch of points at the tips, and run this through a full body IK solver. And now we can just grab each tip of each petal and just move it around and just, randomize our flower a little bit, give it a little bit of an organic feel, instead of this perfectly mathematical thing that we built earlier. And then again, we just apply this to our flower character, to our flower mesh, and we're done here. Now, one thing that you're going to do with every flower setup inside of Houdini is you're going to do some intersecting, and again, KineFX helps us here. We have this one procedural animation up here. We're just going to move each petal up, like this. And then we can just take the thing that we had before already, this Vellum simulation, and just use it to basically de-intersect our petals. Make sure they're not, intersecting with each other. And we're going to freeze frame that. And now we have, first of all, intersected and now a de-intersected flower in here. Yeah, and I seem to be really chuffed about the setup right here. let's see. So we have a KineFX rig for a blossom. We also create a KineFX rig for every other part of a flower. So these are the sepals. These are like the bits in the middle where I forgot the name of. And then, of course, we have the stem. And everything is just one KineFX rig on its own. It's just one object and one skeleton. And then we can bring all those objects together like this, and we have a finished flower. And we can bring all those KineFX rigs together and have a little bit of code to connect them all into one giant rig. And then we have a finished rig flower, and we can just package it up and give it to an actual rigger to build this, for example, into an Apex rig, or to do what I'm doing here and just keep going, keep animating this with your standard KineFX nodes. So what I'm going to quickly do here at the end is I'm using a bunch of different KineFX nodes to just create this little opening animation. And this is how it looks on our finished flower. And then again, to just make it look nice and organic, we're just going to run it through Vellum again, because why not? And this is why we have this sort of closing animation at the front. Again, this is there to sort of stop any kind of intersections. The flower just closes, and then at the end, it can open, and hopefully open quite beautifully. And once you have your simulation, you can then just time shift it, time warp it, make it look nice, make it look dynamic. And this is then the animation that you're left with in the end. And again, the entire thing works for this one flower, but you can easily adapt it to every other flower that you can think of. All right, how are we doing on time? I think we're doing great on time, so we have time for a bonus rig. So let's flip the script here. Now I've pointed to random objects in Houdini and said, hey, that's a rig. Now I'm going to point to a random object in Houdini and say, hey, that's a character. In this case, hey, a volume is a character, because why not try to rig a volume? And on first sight, this sounds impossible, but actually Houdini really makes this incredibly simple. And again, this is our little cloud guy working in here. But I'm first of all going to show a very simple setup, because really it's just that simple inside of Houdini. I'm starting out with a line. This will be both my character and my skeleton. And then I'm just going to use a bunch of subnodes and also one of those old cloud nodes, because again, sort of old setup, to turn this into a cloud character. And then there are these two magical nodes inside of Houdini, which is the lattice from volume node, which takes a volume, turns it into a bunch of points. And then we can take those points and deform them and run it through a volume deform node. And then this node applies this deformation to our cloud in the end. And actually, all these points are perfectly happy to be captured by a KineFX rig. So again, we're taking to take a line, We're going to run both of them through our capture proximity node. And now we just have weights on all our points, which we can then use to animate this using KineFX. So again, just use your typical rig pose node to give it some pose, run through a bone deform, get this pose onto our points, and then run it through a volume deform, and now we have a rig volume. Simple as that. And then for a little cloud guy, what I'm simply doing here is I'm bringing in some animation from Mixamo. Again, I cannot animate, so this is what I'm doing. Then I'm using a bunch of the motion clip nodes inside of Houdini to just extend this animation a bit. And then I'm also going to use the rig of this character to build my cloud character. So I'm going to, first of all, give it an X pose, because this works nicer for capturing. Then I'm going to blast some difficult bits away. Then I'm going to edit it a bit. And then it's the same setup as before to turn it into a cloud guy. And then, before we use the capture by proximity, this is a very simple capture method. We can also use a much more complex biharmonic capturing method as well with a volume, because we can use a bunch of VDB nodes inside of Houdini to turn a cloud dude into this blobby mesh right here. And we can take our rig and this blobby mesh and run it through a TED embed node, which is then the basis to take our points from our volume and run it through our biharmonic capturing node. And now this is using a very advanced capturing method for way nicer weights. And we can animate all of this, run it through a bone deform node at the end. And now we have a little point guy working or walking. And with a volume deform node, we have a cloud guy walking. And now, not the fastest setup, but still we can just animate a volume inside of Houdini. Why not? So, time for a conclusion. So, what I want you to take away from all of this is, yes, KineFX is mainly aimed at character animation, but again, with not much work that we have to put in here, you can do so much more with it. So, just see it as a general tool set of Houdini to add little tweaks or tiny little animations into your setups, no matter if they are a character or just something else. And just, play with the tools. It's really, really fun. I had a lot of fun creating this course back in the day, and I hope you have fun too experimenting with all of this. And I think with this, it's time to say cheers and goodbye. And are there any questions?
I haven't worked with Houdini since for ages, but my question is there some sort of AI built in Houdini to write the code?
You're searching for an AI to write code, was it? Yeah. There are ways to shove it into Houdini. I think we're at this general point on this whole AI journey where just everyone is very tired of the whole AI thing, I find. So this is probably an answer that I will get some flag for in the comments, but I'm going to deal with it. The thing is, yeah, through some API-ish things that I probably need to look up as well, you can get AI into Houdini to write this code for you. And I think different AIs are better or worse at that. Of course, they're going to be better at Python than at Rex because there's just a lot more Python code on the internet than Rex code. And yeah, whether you're using one of those big online models or one of those small models that you can run locally on your machine, which are getting quite good nowadays, there are ways to bring this in. And I think we have one video where we do fun things with it, basically replicating some setups that Will McNeil first showed, where we use it for sort of naming points inside of Houdini or coming up with color ramps. But you can take this and that thing sort of adapt it to writing your code as well.
On that topic, I can tell you the side effects perspective on AI and ML in Houdini, which is that we are going to embrace fully machine learning in Houdini and already are. But we want to make sure that it's an ethical use of ML and AI so that you know where the data is coming from, you know where it's trained. We are fully in favor of using Houdini for creating your own training data, creating synthetic data that you can then train on. But our own team, our side effects team, will always be using AI and ML in very clear, transparent, ethical ways. Having said that, there are some other people out there sort of experimenting with more Gen AI stuff in Houdini and doing some very interesting things with it, and good for them. I'm glad that Houdini is a good operating system for that use case. But like I said, from the side effects perspective, we'll be using ML to sort of supercharge the tools in Houdini. Any other questions for Chris? Yeah.
I have a question because I was a graphic designer so many years ago, and sometimes I had to do motion graphics, and it was super difficult, right? We use another software by the time. But my question is, watching your examples, maybe what I'm going to say is completely out of the topic, or is there a way to, let's say for somebody that doesn't know Houdini too much, is there a way like having a predefined kind of nodes, like I could start as a base of what you are doing? Not trying to converting as a Photoshop, right filters, but you know what I mean, like something more approachable for somebody like I just wanted to.
Yeah, I talked a bunch about we had matrices and stuff, and yeah, it's I would put it in sort of an advanced-ish category of Houdini. If you're just getting started in Houdini with motion design, I think there is a great plugin for that called MOPS, Motion Operators, and I don't think it has many KineFX stuff in it, but it's really great at doing, like, you have tons of little tiny objects in your scene that you want to manipulate in some way. It has tons of pre-built stuff for you that take care of all this matrixy stuff in the end. I think it's very worthwhile learning about matrices because they can save your butt on so many occasions and give you just so many different things or different views on problems inside of Houdini. But again, you shouldn't get started with them. And I think with this, taking a look at mobs is probably a good idea.
Thank you.
It's done by a guy named Henry Foster, who's amazing. And so it's Motion Operators, MOPS, and it's available out there. There's a free version and a paid version.
So I love the concept of where you simmed the rigid body stuff and then you were like, this bit's not quite right, but I can turn it into a rig and edit that one bit. Is, like, if you had like a much, much larger sim, is there potentially a performance hit when you start to get to much larger scale sims? Like your example earlier where you had like lots of points scattered over the top, you had like over 1,000. Like, was that still really performant when you were editing it?
In the end, what you're just manipulating is points with attributes on them. So it's all the large or the heavy stuff with all those pieces is coming after it. I wonder, I haven't tested it with like a really large sim, but I'm wondering if the solution there is just to drop down a split node and split it into like 2 geostreams where you have just the couple of pieces that you want to modify and then all the other stuff just set to the side for now.
Yeah, awesome. That's a good idea.
Anyone else? All right, well, thanks very much, Chris. Great work.
All right, thank you.